Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Alhamdulillah, wassalatu wassalamu ala Rasulillah. Yes, we're now going to section 4.2. And in this section, we're going to talk about solubility of organic compound, of ionic compound. Solubility of ionic compound. You know what's ionic compound? It's metal within a metal to make the ionic compounds. The ionic compounds, some of them are soluble in water and some of them are not soluble in water. All right, we will learn in this section how to find the ionic compound that will be soluble in water and which one will not be soluble in water. Okay, what does soluble means? Means dissolve. So soluble means dissolve. Good. Now, when you put two ions together and they are not soluble in water, they will come out of solution as what's called precipitate. And we call this thing precipitation reaction. Precipitation reaction, this means it will come out of solution. This is example. For example, if you add this soluble compound with this soluble compound, the yellow compound will come out as precipitate. So this is the yellow compound is precipitate. It will come out of solution. How does the ionic compound dissolve? They dissolve by what's called hydration. Hydration means they are surrounded with water. How is that? Look at this slide. Here, this ionic compound with positive and negative ions, it dissolves in water. How does it dissolve in water? It will be actually surrounded. The negative ion will be surrounded by the water molecule, and the positive ion will be surrounded by water molecule, and they will dissolve. Sometimes they don't dissolve. This means they stay as this if it doesn't dissolve. This is what's called precipitate. If it stays like this, it does not go into solution. Okay, and when we say solubility, we means how much is the solute going into solvent? How much solute is available in the solvent? And when you have the solubility means the maximum amount you can find the maximum amount of solute that will dissolve in certain in water. Okay, and as read here very well, not all ionic compounds dissolve in water. This is a very important statement. Ionic compound, not all of them dissolve in water. Some dissolve in water and some does not dissolve in water. Which compound are soluble in water? Okay, look at this table, read it very well and memorize it before you come to class tomorrow. Okay, what is it? Read the title here, water soluble compounds. These compounds are soluble in water. Soluble means will dissolve in water. They will dissolve in water. Dissolve in water. Okay. Now, which compound? First, any compound that contain alkali ions is soluble in water, or if it contains ammonium ion. These compounds are all soluble in water. They will dissolve in water. All compounds containing nitrate ion, NO3- are also soluble in water. All the ions that are the ionic compound that contain acetate, which comes from acetic acid, remember acetic acid, and chlorate ion are also soluble in water. Good. Now, compounds containing chloride ion or bromide ion or iodide ion are generally soluble. Most of them are soluble, except if the chlorine or bromine, chloride or bromide or iodide ion see these ions. If there is Ag+, it will come out of solution as precipitate, or Hg1, or Pp2+. If these things come out of, if there is Ag+ with Cl-, they will come out of solution as AgCl, solid. It will not dissolve in water. Okay, last, compounds containing sulfate ion are also soluble. Is there exception? Yes. If there is Ag or Hg1 or Pp, similar to these, or any of the alkaline earth ions, which is calcium, strontium, and barium. Look at them in the periodic table. These are soluble compounds, but these are the exceptions. Now, when you go to this one, these are not soluble, water insoluble compounds. Insoluble, they will not dissolve. Anything that contain carbonate, phosphate ion, or chromate ion, or sulfide ion are insoluble in water. They will not dissolve in water. Exception if you have alkali ions or NH4+. Also, compounds that contain hydroxide ion are also will not dissolve in water, except if the hydroxide is with alkali ions, or only Ba2+ from the alkaline earth group. I will add to this one also NH4+ also here, which is not ionic compound, but we will put it here as ionic compound. I mean, it's not, it's ionic compound, but it's not different in certain issues. Okay, anyway, so NH4+, I will add it also to NH4 with hydroxide will dissolve in water. Now, we want to see AgNO3, is it going to be soluble? The answer is what? Yes. Why? Because rule number 2 in the table, go back to the table, you will find that rule number 2 says all what? Nitrate ions are soluble in water. So yes, it will be soluble in water. Okay. Okay. B. Or I will go first to C. C, is it soluble or not? We know that carbonate are insoluble, but when carbonate come with potassium, it will be also soluble, because all compounds that contain alkali metals are soluble. So this is soluble, and this is also soluble. But this one, sulfate with calcium are insoluble. So calcium sulfate is also insoluble in water. Calcium sulfate is insoluble in water. You can get this information from the previous 2 tables. Now, when we have 2 ionic compounds reacting, like PpNO3, 2 plus 2Ni, NaI, what's the product? It will be sodium nitrate and PpI2. This is soluble in water, and that's why we write aqueous. This is soluble in water, that's why we write aqueous. This is soluble in water from the rules, and this is why we write aqueous, but this one will come out of solution, and that's why we call it solid. We call this equation molecular equation. we can make this equation as ionic equation or different equation. Even this one here, we have sodium sulfate NaSO4, Na2SO4 is reacting with BaOH2, okay, to give you what? Na2NaOH plus BaSO4. This is the molecular equation. This one is called now molecular equation. Can we make it ionic? Yes. Change everything into ion. This one will go to ions. This will go to ions. This one will be going to ions. This one is also going to be ions. But when they interact with each other, then sodium will be still ion, OH will be ions, but Ba and SO4, it will come out of solution as precipitate, and we call this one now ionic equation because everything is ionic, but we cannot make ions here. Why? Because it is soluble. It's not soluble in water, it's insoluble. Now, if you notice, we have 2 sodium here in the reactant and 2 sodium in the product. We can cancel them with each other. We have 2 OH minus in the reactant and 2 OH minus in the product. We can cancel them together. What will be left? SO4 2 minus plus Ba 2 plus give you what? BaSO4 solid. This is now we call, it's ionic equation, but we call it net ionic equation. Net ionic equation. All right. And we call these ions, which is sodium, we call it spectator ion. What else? Spectator ion. OH minus and 2OH minus are spectator ion. What do we mean? They don't do anything to the reaction. They just watch the reaction. That's why they call it spectator ion. Okay? And that's the net ionic equation. All right. Tomorrow I will ask you to write the to solve this problem by writing the equation, the molecular equation, and then the ionic equation, and then the net ionic equation for this example, and we'll stop there. All right. Thank you, and see you inshallah tomorrow.